They're small, striped, and easy to overlook, but without resistors, your antique radio wouldn't even function. How do you read those colored bands, test a resistor to see if it's still good, or know when it's time to replace one? Stick around because in this video, we're going to break it all down. Hi everyone, and welcome back to the Old Radio Revival. I'm Jim Hounsell. Today we're going to talk about a component that might seem simple, but it's absolutely essential to every circuit, the resistor. A resistor has one primary job, to control the flow of electrical current. It provides just the right amount of resistance to ensure that each component in the circuit receives exactly the voltage it needs, no more, no less. Get the resistance wrong and disaster follows. Too little resistance and sensitive components get fried by excessive current. Too much resistance and the circuit can't function at all. There's not enough power flowing to make anything work. Fixed resistors are precisely color-coded to show its exact value. There's no guesswork. The circuit designer calculated exactly how much resistance is needed at each point, and that resistor must match perfectly. It's all about controlling the flow, allowing what should pass through while blocking what could cause damage. This principle reveals a profound spiritual truth about our lives. We need the right kind of resistance in exactly the right places. James 4:7 gives us this crucial instruction. Submit yourselves then to God. Resist the devil, and he will flee from you. Notice the balance here. Submit to God, resist the devil. We must know precisely where to yield and where to provide resistance. Too many people get this backwards. They resist God's will for their lives while yielding to temptation, sin, and worldly pressure. That's like putting resistors in the wrong places in a circuit. It creates spiritual damage. When we resist God's guidance, His love, and His truth, we block the very power we need to live abundant lives. But when we resist sin while submitting to God, we create the perfect spiritual flow. 1 Peter 5:8 and 9 warns us, "Be alert and of sober mind. Your enemy, the devil, prowls around like a roaring lion, looking for someone to devour. Resist him, standing firm in the faith." We're called to provide strong resistance against Satan's attacks while maintaining complete openness to God's Spirit. The gospel teaches us exactly where to resist and where to surrender. Through God's word, we learn to resist pride, selfishness, and ungodly desires. Through the example of Jesus, we learn to yield our will completely to the Father's plan. This isn't complicated, it's precisely calibrated, just like the colored bands on a resistor. When Jesus faced temptation in the wilderness, He demonstrated perfect spiritual resistance, resisting Satan's lies while submitting completely to Scripture and to the Father's will. He provides our pattern for the right resistance in the right places. So as we examine these precisely valued resistors that provide proper current flow to vintage radios, consider the spiritual resistance in your own life. Are you resisting God's will and yielding to sin? Or are you providing strong resistance to temptation while submitting completely to your loving Father? The gospel shows you exactly how to get the flow right. Thanks for tuning in. Now, let's talk about resistors. Resistors might not be as glamorous as tubes or as mysterious as transformers, but they're absolutely crucial to proper radio operation. A single bad resistor can make your radio completely silent, cause distortion, or create dangerous operating conditions. In this video, we'll talk about what resistors are, how they work in radio circuits, how to identify and test them, and when to replace them. This knowledge is essential because, like capacitors, resistor problems are among the most common issues you'll encounter in vintage radio restoration. So let's start with the basics. What is a resistor? Think about trying to drink water straight from a fire hose. The water comes out with so much force it would knock you down. You need something to slow it to a manageable flow. That's exactly what resistors do inside your radio. Resistors don't store energy like capacitors. Instead, they restrict and control the flow of electricity. By doing that, they drop voltage and limit current to just the right levels a circuit needs. Not too much, not too little. This control is essential. Resistors protect delicate components, create the voltage drops needed to power tubes correctly, set bias conditions for amplifier stages, and even help shape the frequency response and gain of various circuits. Understanding how resistors work in radio circuits will help you troubleshoot problems and choose proper replacements. So let's take a look at some of their most common jobs. Resistors are used for creating voltage dividers. The high B plus voltage from the power supply, maybe 250 or 300 volts, is too high for some circuit stages. By using resistors in series, you can create lower voltages. For example, if you put two equally valued resistors in series across 300 volts, you'll get about 150 volts at the junction between them. This technique is used throughout vintage radios to create the different B plus voltages that tubes need for proper operation. Resistors also protect components by limiting current flow. Take tube filaments, for example. They need a very specific current to operate properly. Too much current and the filament can burn out. Too little current and the tube won't function at all. By placing a resistor in series with the filament circuit, the current is limited to exactly the right amount, protecting the tube from damage and ensuring reliable operation. Every amplifier tube needs the right bias voltage on its control grid. This bias is what sets how the tube works, how much current it uses, and how it handles the signal passing through it. A common way to create this bias is with a cathode resistor. As the tube operates, current flows through the resistor, causing a small voltage drop. This makes the cathode a little more positive than the grid. Since the grid is now negative compared to the cathode, the tube gets the proper bias it needs to run smoothly and reliably. In some circuits, resistors are used as load resistors. When a tube boosts the input signal, the stronger signal shows up as a changing voltage across the load resistor. This method is often used in voltage amplifier stages, where the goal is to make the signal's voltage larger, high gain, rather than deliver a lot of power to the speaker. Plate load resistors are connected between the tube's plate and the B plus supply, and they serve several important purposes. They limit the amount of current flowing through the tube, which protects both the tube and the circuit from damage. They also develop the amplified signal as a voltage across themselves, which is then passed along to the next stage. In addition, when working together with nearby capacitors, they help shape the frequency response of the circuit, affecting how different tones are heard. Grid leak resistors provide a path for tiny amounts of grid current to flow without loading down the input signal. Without a grid leak resistor, the control grid can accumulate an electrical charge. When that happens, the tube can block the incoming signal, causing a distortion or in some cases a complete loss of signal. Resistors and capacitors often work together in decoupling networks to prevent unwanted feedback between stages of a radio. In these networks, the resistor limits the current flow, while the capacitor provides a low resistance path for the alternating current signals to bypass certain points. This combination helps stabilize the circuit and keeps each stage operating independently without interference from others. Those are some of the key jobs a resistor performs in a radio circuit. Now let's take a look at the different types of resistors you'll encounter and what makes each one unique. Let's start with carbon composition resistors. Carbon composition resistors are by far the most common type in vintage radios. They're made by mixing carbon powder with a clay binder, molding it into a small cylinder, and attaching wire leads. The resistance value depends on the ratio of carbon to clay. More carbon gives lower resistance, while more clay gives higher resistance. Carbon composition resistors are inexpensive, come in a wide range of value, and can handle reasonable power levels. The big issue for restoration work is that their values can drift upward over time, especially if they've been exposed to heat. Carbon composition resistors come in various power ratings. 1/8 watt, 1/4 watt, half watt, 1 watt, and 2 watts are common. The higher the power rating, the physically larger the resistor. Carbon film resistors appear in later tube radios, mostly from the 50s and early 60s. They're made by depositing a thin carbon film on a ceramic substrate rather than mixing carbon and clay like the older carbon composition resistors. Carbon film resistors are more precise, typically around 5% tolerance, and are more stable over time. They also have better noise characteristics, making them preferable in audio circuits. Another type of resistor you'll encounter is the wire-wound resistor. Wire-wound resistors are made by winding resistance wire around a ceramic or fiberglass core. Their resistance depends on the wire material, the diameter, and the length. These resistors are very precise, often 1% tolerance or better, and they can handle high power levels. They're extremely stable over time and temperature, which makes them ideal for critical applications. Because of the wire windings, they have some inductance, which can affect high-frequency performance. They're usually larger than equivalent carbon resistors and more expensive. You'll often find wire-wound resistors in applications like cathode resistors for output tubes, voltage divider chains in power supplies, and precision bias networks. Variable resistors, also called potentiometers, are another type of resistor. They allow you to adjust the resistance by turning a shaft or moving a slider. They consist of a resistive element, usually carbon composition, carbon film, or wire wound, and a movable contact called a wiper that slides along the element. Potentiometers are commonly used for volume controls, tone controls, and other adjustable settings in vintage radios. By changing the resistance, you control how much current or voltage reaches a particular part of the circuit. Common problems with potentiometers is that the resistive element can wear out, causing scratchy or intermittent operation. Also, the wiper contact can become dirty or corroded, and the mechanical parts can wear out. So let's talk about the resistor's color code system. As we saw, fixed resistors have colored markings on them to help us identify the resistance value. Each fixed resistor has a value measured in ohms, and that value is shown along with its tolerance using a color code. Knowing how to read this code is something every radio restorer should know. Let's start by looking at the 4-band color code system. The first band represents the first digit of the resistance value. The second band represents the second digit, and the third band, called the multiplier, tells you how many zeros to add after those digits. When a fourth band is present, it indicates the resistor's tolerance, showing how precise its value is. For example, a silver band means the resistor should be within 10% of its stated value, while a gold band indicates a 5% tolerance. If there's no fourth band, the resistor's value can vary by as much as 20%, plus or minus, and still be considered acceptable. To read a resistor's color code correctly, read it from left to right, placing the end with the 3 bands grouped closer together on the left. The first band to read then will be the one nearest to a lead, while the opposite end will usually have a band set further away. Another reliable way to confirm orientation is to look for a gold or silver tolerance band. When present, these tolerance bands are always on the right side. Now let's use this color code chart to help us determine a resistor's value. Our first example is red, red, brown, silver. So from our chart, we see that the first digit, red, is 2. The second digit, also red, is 2. The multiplier, brown, is 10, so you can multiply 22 by 10 and you'll get 220. But if you want to skip the math, look at the number assigned to the color. Brown is 1, so put 1 0 at the end of the 22. The result is the same. The resistor is a 220 ohm resistor. Now the fourth color, silver, tells us the tolerance, plus or minus 10%. So if you are checking resistors in your radio and your 220 ohm resistor measures 10% above or below 220, that is, above 242 ohms or below 198 ohms, you should consider replacing it. Let's try another one. Yellow, violet, orange, gold. The first digit is 4. The second digit is 7. And the multiplier is orange, which indicates 3 zeros. Put it all together and we see that the value of this resistor is 47,000 ohms, or 47K, with the K standing for kilos, or 1,000. The last color, gold, tells us that there is a tolerance of plus or minus 5%. Let's do one more. Green, gray, black, with no fourth band. The first digit is 5. The second digit is 8. The multiplier is black, which is 0 on the chart. So that's how many zeros we add to the end of the 58. None. This resistor is 58 ohms. Since there is no fourth color band, the tolerance is plus or minus 20%. Use a color code chart like the one shown here, and over time as you troubleshoot and replace resistors, reading the color code on resistors will become second nature and require very little effort. Early resistors used a different color code system. They were referred to as dog bone resistors. They got their nickname from their shape, a long central body with rounded ends like a dog's bone. These resistors were widely used in the 1930s and early 1940s, before the more familiar carbon resistors became common. As you can see, dog bone resistors don't use the wraparound color bands we just discussed. Instead, they use what's called a body-end-dot system. It works on the same principle as the modern code, 2 digits followed by a multiplier, but the colors are placed in different locations. Here's how you read one. The color of the main body gives the first digit. The color on one rounded end gives the second digit. The colored dot in the center of the body tells you the multiplier, or how many zeros to add after the first 2 digits. The easiest way to remember the order is by using the acronym BED, BED, which comes from the first letters of each word. The opposite end, the one without a digit color, is often left plain. Sometimes it was painted to indicate tolerance, but in many early sets, no special tolerance marking was given. These were often assumed to be plus or minus 20%. Let's walk through an example. Suppose you find a resistor with a red body, a black end, and a yellow dot. Red on the body means the first digit is 2. Black on the end means the second digit is 0. The yellow dot in the middle means add 4 zeros to the end. So that resistor's value is 200,000 ohms, or 200K ohms. Here's another one. A green body, a blue end, and a red dot. Green body, 5. Blue end, 6. Red dot, 2 zeros. So 56 and 2 zeros makes 5,600 ohms, or 5.6K ohms. As you work on older radios, you'll encounter these type resistors often enough, so it's worth being comfortable with their color code system. Unlike capacitors, you don't need to automatically replace every resistor in a vintage radio. Instead, you only replace the ones that test bad or show signs of failure. Always start with a visual inspection. Several signs can reveal a failing resistor. If the body appears discolored or darkened, especially with brown or black spots, or if the color bands are badly faded or unreadable, overheating is likely. Carbon composition resistors may also swell as they age or overheat. In either case, the resistor should be replaced. Other visual signs that resistors need replacement include a cracked body, broken leads, or obvious burn damage. Green corrosion around the lead wires, especially where they enter the resistor body, is another indicator. If you see any of these conditions, the resistor should be replaced immediately. Once you've identified and removed any resistors with obvious physical damage, the next step is to test the others with a digital multimeter. For an accurate reading, lift at least one end of the resistor out of the circuit before measuring. Compare the measured resistance to the value indicated by the color code. If the reading falls within the specified tolerance, the resistor is probably good and doesn't need to be replaced. But you may come across a resistor that looks fine and even measures within the proper range, but still fails to work correctly once it's in the circuit. In these cases, the best clue is often the symptoms the faulty resistor causes. For example, if there's no B+ voltage, check for an open voltage dropping resistor in the power supply. If there is low B+ voltage, a voltage dropping resistor has likely increased in value. If there is no bias voltage, suspect a cathode resistor that has gone open. If measurements show the wrong bias voltage, the cathode resistor has probably drifted in value. When there is distortion or weak audio, resistors in the audio chain may have changed value. And when there is no output, look for an open plate load resistor or a failed coupling resistor. Most schematics list the correct values for all resistors, and many also show the voltage you should expect at key points in the circuit. If your measured voltages don't match the schematic, you can work backwards through the circuit to find the resistor that has likely drifted in value. There are a variety of modern-day replacements that will work in your vintage radio. Which one you use is up to you, but some will be better suited than others depending on the application. For example, modern carbon film resistors are the best general replacement for carbon composition resistors. They're more stable, more accurate, and last longer. Metal film resistors offer even greater accuracy and stability. While they are slightly more expensive, they are an excellent choice for critical circuits where precision is important. If you want to preserve the original look of your radio, carbon composition resistors are still available. However, modern resistor types generally offer better performance and reliability. Wire-wound resistors are ideal for high-powered applications or circuits that require very precise values. They are commonly found in power supply sections and other low-frequency circuits where durability and accuracy are critical. When choosing replacement resistors for an antique radio, it's important to pay close attention to the power ratings. The power rating defines how much electrical energy a resistor can safely dissipate as heat without being damaged. This helps prevent overheating, premature failure, and possible damage to nearby components. In tube circuits, for example, a single resistor may be exposed to both high voltage and high current, leading to significant power dissipation. To stay safe, always use a replacement resistor with a power rating equal to or higher than the original. If the original rating isn't known, then keep this in mind. 1/4 watt resistors are found in most signal circuits and low current applications. 1/2 watt resistors are used for cathode resistors in small tubes and in moderate current applications. 1 watt resistors are used for cathode resistors in power tubes and in high current applications. And resistors of 2 watts or higher are used in the power supply as dropping resistors and in other high-powered applications. When in doubt, go with a higher power rating. It won't hurt anything and will increase reliability. The time you spend understanding resistors will pay off in more reliable restorations and better performing radios. They may be small and simple, but resistors are vital to every stage of your radio's operation. And the good news is, once you've learned how to recognize, test, and replace them, you've taken another big step to mastering antique radio restoration. I hope you found this information to be of value to you. Give it a thumbs up and please subscribe to the channel and check out the other videos in my beginner series. Thanks for joining me, and I'll see you in the next one.